Good day, everybody. My name is Sebastian Raveau, and I would like to welcome you to this webinar organized by the BRT Center of Excellence. Today I'll be talking about my PhD dissertation. I've been working for the last 4 years as part of this center about modeling mode and route choices on public transport systems. Of course, this presentation I'll be showing you is not only of my own, but I have the opportunity of collaborating with a lot of researchers of my university here in Chile and in different universities around the world, thanks to the network that our center has put up together. To understand the type of analysis I'll be presenting today, let's analyze this example. This is a part of the Santiago Metro network. Hopefully some of you know this system. And let's assume that we want to analyze a given trip from one origin to one destination in this quite small and simple network. For doing this trip, we have two alternatives. We can take at the origin station the red line, then transfer to the green line and arrive to the destination. Quite simple, one transfer. Another alternative would be okay. As we are beginning our trip from a transfer station, we can choose the yellow line as our first line and then transfer to the green line in a different station and then arrive to the destination. Once again, this is a simple route, only one transfer. So we have two alternatives, both quite simple. Why would a given individual making this trip choose either route? And that's based on the attributes, how the level of service on both routes is. So again, as I mentioned before, we have two alternatives, taking the red line or the yellow line. Both alternatives have one transfer, so in terms of transfer, no difference. If we analyze the time, because we know people want to get to the destination as fast as possible, we can see that in average, taking the red line route takes 23 minutes and 40 seconds, and taking the other route through the yellow line takes only 3 more seconds on average. So in terms of travel time, we can say that quite really similar. We don't think that people can actually perceive those average 3 seconds of difference. So what else can we analyze? How occupied the different routes are. If we analyze the density, how many passengers per square meter are along the route, if we take the red line, first we'll experience 5 passengers per square meter, because that part of the network, the red line, is the city center and is the most congested part of the network. If we use the second line, the second route, through the yellow line, we only experience 3 passengers per square meter, so it's much more comfortable. And maybe a fourth attribute we can analyze is how crowded the first leg is. As I mentioned before, our example begins the trip at a transfer station, so we can choose to take either the red line or the yellow line. And on average, to that station, to the origin station, in the red line, we have 90% of occupancy in the trains. This means that maybe there's a chance that we won't be able to board. Maybe the train will arrive to the station really crowded and we won't be able to board the first one. Maybe we have to wait 2, maybe 3 trains. But if we take the yellow line, on average, the trains arrive to the station at half capacity, so there shouldn't be any problem to take the trains in that line. So just by analyzing these simple 4 attributes, we can say that taking the second route to the yellow line seems to be better. So what do people do? 9 out of 10 use the red line. That means, based on our attributes, that 9 out of 10 travelers are making a bad decision based on the characteristics. How can we understand that? That's the main idea of my research, try to understand the people's behavior. We can argue that taking the best line through the yellow line seems counterintuitive, as we are going to a destination to the south of the origin, but this route begins going to the north. So people may try to avoid this route that seemed to be not really logical, but they're actually better in terms of level of service. So these kind of things are really important. So how do we change these travelers' decisions? How do we make them choose something that's better for them and for everybody? And why is it better for everybody? Because as I mentioned, the red line in the city center is the most crowded part of the network. So if we can make at least some travelers making these trips and similar kind of trips, change their decision, the changed passengers will be better because the level of service was better, and the rest of the passengers will also be better because the red line will now be a little less crowded. So our objectives are to identify and quantify the factors that affect the public transport user behavior in terms of how they choose modes and routes. We also like to explore difference across modes in a multimodal public network, and also compare the preferences and behavior of different users in different systems and contexts. So the main content of this presentation will be a brief background on route choice. I'll present a first study case which deals with only metro networks, a second study case which deals with multimodal networks when we include metro and buses in particular. I'll present, of course, the results analysis of these study cases, some extensions and applications, and finally, of course, some conclusions to the study. So, what can we say about route choice modeling? Traditional route choice models only consider, or usually consider, tangible variables related to the level of service, such as travel time, fare, number of transfers. And these models are sometimes refined, if the information is available, using socioeconomic characteristics such as income, purpose of the trip, age. But we also know that there are other kind of variables that are not tangible, that can actually influence the decisions or route of the travelers, such as comfort and safety, transfer accessibility, the topology of the network, as I showed before in the example, or something that as aesthetics. The problem with these variables is that they're really difficult to quantify. Because, for example, we know that comfort is important to everybody, but how do we measure comfort? There are many things that can influence the perception of comfort. And even if we manage to come up with an expression of how to quantify this comfort, this is really subjective. Different people will perceive the same level of service differently. So, okay, how do people choose how to travel? This is an example I always like to use with my students or when I give a talk. And I ask everybody, okay, this is the Tokyo Metro network. Let's assume that you don't know anything about the city and you're trying to make a trip between these two stations, marked here in a blue square. How will people tell me how they will make the trip if they know the city, the system as well? They tell me, okay, I'm traveling from a station that's in the blue line to a station that's a transfer station that can be reached through the yellow line and the pinkish line. So we can just simplify the map and analyze only the lines that are interesting to this kind of trip and say, okay, maybe I can take maybe I can take the blue line here, then transfer in that station and go down to the destination station through the pink line. Or maybe at the origin I can take, of course, the blue line, but come further to the south and then transfer in this station through the yellow line and then arrive to the destination. So we have two alternatives, and these are the two alternatives that I always get as an answer when I make this question. And what the people that are answering are actually doing is minimizing transfers. They say, okay, I have to transfer because I'm traveling between two stations that are in different lines, so I have to transfer. Let's find a way of only making one transfer. And maybe a second answer I usually get is try to minimize the number of stations that you have to go along the way, because you can say, okay, the more stations I pass through, the more stops the train will make, and the longer time will take me. And that maybe is a way of choosing between these two lines these two routes, that only have one transfer. So we can say, okay, the type of answer I'm getting is, okay, let's try to minimize transfer. And that's actually one criteria to travel in different systems. And different people follow different criteria. For example, one traveler may be interested in getting or finding the fastest way to the destination. Others might try to find the cheapest way if there are fare differences involved. Maybe other people want to avoid walking, avoid transferring, especially if they, for example, in wheelchair or have a reduced mobility. But most people, we have found, that consider these factors and many factors at the same time. They're not only minimizing transfers or time, but they're considering an aggregated level of service, and based on this aggregated level of service with many factors, try to choose the best way for them. And these factors depend, of course, on the preferences of the people, what people want, and the information provided. And if you go to any journey planner around the world, this is, for example, the journey planner for in London of TfL, and you can see that this planner offers you different alternatives. For example, find the fastest route in terms of time with the fewest changes. This is minimizing transfers, maybe with least walking, and also adds you the different options if you're cycling or if you have different mobility requirements. But like in every city I've been to, I've come across with journey planners that only minimize one aspect. For example, the less transfer, less time, less walking. And no journey planner that considers these factors or many factors at the same time. So what we did, is to analyze the decisions of metro travelers in Santiago and London. We used two surveys of almost 29,000 respondents in the case of Santiago and 16,000 respondents in the case of London. London, of course, is a much bigger city with a high population, a much bigger network. So it would be interesting to analyze these two different networks in terms of size, at least. So what we found that people take into account, first of all, the in-vehicle time. It's by far the most important variable. People want to get to the destination as fast as possible. But not only the in-vehicle time, but the waiting time, especially if you have to transfer and wait many times. The walking time, and this walking time is related to the transferring time from platform to platform along the way. And these three are the time components, different travel time components that people may perceive differently. Another variable really important is the number of transfers, but not only the number of transfer, but the transfer quality. And we analyze different transfers in terms of layout. For example, if the transfer is ascending at level or descending, and different transfer infrastructure. If the transfer is assisted, it means I can make the transfer either by escalator or elevator. If it's semi-assisted, which means that I can make a part of the transfer in elevator and escalator and the other part of the transfer on foot, or the worst case, if the transfer is not assisted and I have to walk all the way. And this has to do with the transfer experience. We also found out that the mean occupancy as a proxy of the comfort is really important. And we found out two extreme cases. When the occupancy is high, we also found that there's a possibility of not boarding. This happens in London when the occupancy is 75% or higher, and in Santiago 85% or higher. And on the other hand, maybe there's a possibility of getting a seat if the trains are not really that crowded. And we found out that in London, if the initial occupancy, the occupancy at the initial station is 25% or lower, maybe there's a chance of getting a seat. And in Santiago, it's a 15%. The threshold is 15% of occupancy. And these three have to do with comfort and crowding. We also found that route distance is important. People, just looking at the map, for example, we try to find the shortest route in the map. The number of stations that you have to pass along the way as a proxy of how long it will take you. An angular cost, which is a measure of how direct a given route is, and how did we define this angular cost? It's a summation of distances and angles, which mean nothing to you, I know. So I'll show you an example. Let's assume that we want to make a simple trip from an origin to destination. Unfortunately, there's no direct line connecting these two stations, so we have to transfer twice to get to our destination. Ideally, we would like to travel directly to the destination. If there's no direct line, we can, so we have to go to a first transfer station. So there's an angle between where I want to go and where I'm actually going. And in that angle, we're traveling a distance d1. That's the distance to the first transfer station. So we have a penalty that's related to the angle and the distance we're traveling along the way. Once we're in the first transfer station, again, we would like to go direct to the destination. Once again, we can't. We have to pass through a second station. So there's a second angular penalty here that comes with the second term of the angular cost. And then once we are in the second transfer station, we can finally go direct to the destination. So there's no third penalty term. Okay, so that's how we define the angular cost. We tried different specifications to measure this angular penalty, and we came that this expression here was the best one to reproduce and explain the people behavior. So we have the angular cost, which is topological, and we also have two additional variables that have to do if the route is reasonable. Understanding a reasonable route as the definition of Dial back in the 70s. And in this case, if a route at any point along the way takes you back to the destination, or in the direction of takes you back in the direction of the origin, or takes you away from the destination, any of these two cases, then the route will not be reasonable and would have a penalty. And all of this has to do with topological variables. And the main advantage of these new variables that are really common, the angular cost, the transfer infrastructure and layout, the possibility of not boarding, etc., are they're really easy to obtain. For example, the angular cost, you only have to look at the topology of the network and make some calculations. You don't have to make any service. It's really cheap to come up with this new information to help improve the model. And in terms of the topological variables, the angular cost and this reasonable route, we would define them looking at the real topology of the network or the map representation of the network, which of course is distorted because maps have to be distorted in order to accommodate information and to provide different things such as station names or other kind of information that can be provided through maps. So we tried both specifications, and we found that using the map to explain the decisions much better than using the real topology to explain the decision of the travelers. So we define these variables in terms of the map. And we want to understand the impact of a schematic map and user behavior. For example, this would be the real topology of the Santiago Metro network, and this was the topology showed to the users through the map. You can see that there's mainly a big distortion in the city center, precisely where the example I showed you at the beginning was. But okay, that's not much distortion because it's a fairly small network. But for example, this is the real topology of the London Underground network, and this is the famous London Underground map. The distortion here is much bigger and could influence much more the decision of the travelers. So for each city, we have the actual route choices by the individual coming from the survey, and we generated different alternative routes, the non-chosen routes, to try to analyze why the travelers chose the route they are taking and not all the possible routes from origin to destination. And we estimated a C-logit model, which is a probabilistic model that takes into account correlation between alternatives to try to understand and model the preferences of the travelers in both cities. What we found, a lot of parameters, that's not really important to look at the numbers. We can just say that all the parameters signs are okay, and all the parameters are significant. This means that all the variables I mentioned before, which are quite a lot variables, help to understand at some point the decisions of the individuals. Everything is important. But instead of analyzing parameters per se, it's much more interesting to compare and analyze the marginal rate of substitution, how people value some attributes in terms of another. For example, what I'm showing here is how people value different attributes in terms of in-vehicle time. For example, let's analyze the travel time components. We can say that in London, 1 minute of waiting time is 65% more valuable than 1 minute in a vehicle. And Santiago is 46% more expensive. While walking in London is only 15% more expensive or more valuable, while in Santiago is 62%. So we can say that in London, people tend to value more waiting, and in Santiago, people tend to value more walking, as if we want to compare those cities. If we analyze a basic transfer, because let's remember that we're analyzing different kinds of transfers, but just a basic transfer, the fact that you have to transfer, it's valued really similarly in both cities. In London, people are willing to travel 6.6 additional minutes in vehicle to avoid one transfer. And in Santiago is 6.63, really similar. If we analyze the occupancy variables, we can see that in London, it's much more valuable to the occupancy. Travel in crowded trains, it's avoided by Londoners more than people in Santiago. But in Santiago, people care more about getting a seat or not being able to board. They have higher valuations than in London. And finally, we can obtain different valuations for the topological variables, and we can see that in all three cases, these valuations are higher in London than in Santiago, precisely because the map is much more distorted, so this kind of distortions are more important in the decision-making process of the travelers. So before I mention the basic transfer, let's analyze all the different transfer types based on our definitions. We can have transfer ascending at level or descending. Those can be assisted, semi-assisted, or not assisted. And after transfer, we can actually maybe get a seat, not being able to board. And all these possible combinations give different transfer valuations. We can see that the best possible transfer in London is a transfer at level, when maybe you can get a seat, and that transfer is valued 3.35 minutes of in-vehicle time. And the worst possible transfer would be a ascending transfer, non-assisted, where maybe you won't be able to board, and you have a valuation of 12.5 minutes of in-vehicle time. That's the transfer people are willing to travel more to avoid. This is for London. We can do the same for Santiago. And if we compare the same type of transfers in both cities, in all cases, the valuations in Santiago are higher than the valuations in London. This means that people in Santiago care much more about transferring than people in London. So we conducted this metro experiment, and we wanted to expand this analysis to an entire transit network. So we conducted a survey in Santiago, a fairly big city, 7 million people, on which every day we have 10 million trips. 55% of these trips are done in public transport mode, which is quite a lot. Just a quick background of the transit system in Santiago. It's called Trans-Santiago, and it's organized into 10 operational areas, zones. And we have 4 different kinds of vehicles, of modes. Feeder bus lines that usually travel inside each of these zones. The trunk bus lines that connected the different zones in the city. We also have express bus lines that go from point to point with high demand. And we also have, of course, the metro, which is depicted in red in the figure. So we have these 4 modes that people can choose to travel in the system. We conducted a survey in the yellow dot here in the figure. In this point of the city called Plaza de Maipú, in the south of the city, nearly 30,000 daily trips are made in the morning from 7 a.m. to noon. And this is 1% of all the trips in the city on this period, which is quite a lot. Just imagine that in only one part of the city, one point of the city, 1% of all the trips either begin or transfer. So this point was really, really efficient in terms of data collection. We got almost 1,900 respondents, and one of the advantages of this point where we conducted the survey is that people had access to all 4 different kinds of modes of the system. So we wanted to expand the behavioral model I showed before that was conducted only for Metro to the entire public transport system. Also, we have to add some new explanatory variables. First of all, the fare, which is the second most important variable with the travel time. Inside the Metro systems, as I showed before, there was no fare difference between alternatives, but now that we have different modes and different modes with different fares, fare can be actually be an important variable to understand the decision of the travelers. We can distinguish travel times by mode because maybe people perceive traveling in Metro as much better than traveling in bus. We can distinguish different transfers involved because maybe it's not the same transferring inside Metro than transfer from Metro to bus or between buses. And we can also include some measure of variability of the in-vehicle and waiting times. Because the study I showed before, in Metro, both Metro systems were so reliable that it was not possible to introduce any kind of variable related to the variability. But now that we have buses and different kinds of modes involved, it is possible, and it's really an interesting thing to do. And an additional challenge that we came up with when we conducted this study was to analyze different strategies of traveling when we have a frequency-based network. What does it mean? People actually can choose an itinerary, which is okay for each leg of the trip, from origin to destination, passing through transfer points. I'll choose one line and only one line on any leg of the trip, or we can choose an hyperpath, considering common lines. This means that, okay, at the origin, in this example, for the first leg of my trip, I'll choose the first line that passes between these 3 lines. Then maybe I'll choose only one, and then for the last leg of my trip, I'll take the first between 2 lines that passes through the stop. So we have common lines. People don't only choose a single line, but maybe the first among a set of lines. And that's something that we didn't have before for the Metro case, and we have now for the entire system. What we found that 2% of the travelers, 2/3 of the traveler that could choose the routes considering common lines, didn't consider common lines. These 2/3 decided to wait for a single particular line instead of taking the first that passes through the station. So one might argue that consider common lines is a personal characteristic that not everybody behaves in the same way in terms of how strategies are considered. So what we proposed was to model 2 types of individuals, those who consider common lines and those who don't. So we have 2 types of individuals traveling in the network and making decisions. How we explain the probability of considering common lines through a logic model that considers socioeconomic characteristics of the individuals. So what we have here are the parameters of the probability of considering common lines. We included the income, the frequency of the trip, and the age as explanatory variables. What we can see is that the higher the income, the more likely the individual is to consider common lines. The higher the frequency that the trip is made, for example, at least once a week or every day, the higher the probability of also considering common lines. This actually makes sense because the more frequent the trip is to the individual, better the understanding the individual has about the different alternatives and a better decision she can make. And finally, we have found that younger people younger than 30 years old in this case had a higher probability of considering common lines. So these three explanatory variables, also socioeconomic, help us understand why some people consider common lines and why some people don't. We estimated a route choice model. This is the first model. This is not a definitive work, so you can see that we don't have all the variables, but it's a study that's on progress right now. And once again, what's interesting is to analyze the material of substitution. In this case, as we have FAIR, we can come up with monetary evaluations for all the attributes. For example, in this case in Santiago, we can see that people that consider common lines have a value of time of 1.35 euros per hour of in-vehicle, 3.5 euros of waiting, and 4 euros for walking. And all these valuations are higher than for the people that do not consider common lines. So you can see that there's actually a difference between both types of individuals inside the population. Their perceptions are different in terms of valuations. So, what have we done with all the studies, these results we have been getting for the last years? The first thing we did, and when we came up with the metro results, was to approach the metro authorities here in Santiago and tell them, okay, the map is important and any distortions can influence decisions. So they changed the map. You can see that the part that was more distorted, the downtown, the center of the city, now it's much more, it's less distorted and much more similar to the real topology. And it's actually really nice to be able to say that we approached the authorities and we changed the metro map on our city based on our results. Luckily, we were heard, and the authorities took our recommendations into practice. We are also trying to apply this model to different cities and systems. We applied this to Santiago, to London. We have some different data from different parts, and it's always interesting to compare the preferences of travelers in different contexts. We can also use these results for map design optimization, because, for example, in Santiago, in the next 5 years, we'll have 2 new lines, so the map will have to be redrawn. And an interesting question is, how do we come up with a new map that considers the perception of the individuals and the impact the map has on the decisions? We can also use these results to a journey planner, and instead of just offering the route with less transfer or less time, maybe we can offer a route with higher utility, or a route that at least considers many attributes at the same time and not only one to come up with the solution. So just a matter of conclusion, because I'm very interested in the questions that may come. We can say that public transport users take into account a wide variety of attributes when choosing routes. It's not only time, it's not only fare, but the many things that are important for travelers. That the modeling effort should be on what can be explained rather than what can't be explained. So instead of just coming up with a simple model with only fare and only time, we should make an effort to try to include all the different possibilities, all the different attributes and characteristics that people do take into account. And this way we can come up with better models in terms of understanding and forecasting. It's also that the network topology is really important, and it's not only the topology it's important, it's the way it's presented through maps that's relevant. So an effort should be made on trying to analyze how different maps are influencing the decisions. And finally, we can say that different individuals follow different strategies when choosing routes. And on practice, what it's usually done is to assume that everybody in the population behaves in the same way in terms of strategies. We found that this is not a really good solution and should be important to try to model different strategies in order to accommodate different behavior inside the population. But most importantly is that we shouldn't forget that we're dealing with individuals whose behavior is really hard to understand and model. So it's not only mathematical models that we're dealing, it's people. Thank you very much. So now I'm open to questions. Hopefully you have many questions because we have plenty of time. Thanks. Are there any questions? If you have any questions, I got the first one. If you have any question, you have a question box in the panel of the options where you can just type in the question, and I'll read it to everybody and I'll try to answer it as best as I can. So we have our first question from David. Have you ever recommended to change a map to make it less like reality, to try to encourage people to use a less busy route? It's a really good question. The thing with the distortion of the maps is that when maps are designed, are usually only considering design variables, that it should be easy to read, that it should be attractive colors, and should provide information quickly, and all of that is really important. But also, as I mentioned, different maps can influence different decisions. So our proposal is not precisely to try to reduce the distortions of the map, to try to make it much more like reality, but maybe we can use maps as a tool, of a planning tool, to try to induce certain behaviors. If we have a congested route, maybe we can make it less appealing in the map and try to force people, maybe not force, but encourage people to use different alternatives for the trips. Alternatives, as I mentioned in the example, that are not necessarily worse for them in terms of travel time or occupancy, but maybe try to highlight some different alternatives in the map. So yeah, definitely maps can be used as a tool to induce certain behaviors. Do we have any other questions? If you have any question, just type it into the question box and I'll try to answer it. No more questions, I see. Okay, we have a second question from David. What type of service did you use to work out the different values of time associated to different parts of the journey? Static preferences or reveal preference? So, okay, all the information gathering process was through stated preference service, and we actually approach the travelers and ask them for the trip you're making right now, which route are you taking? And based on the decisions, the actual route chosen by the individuals, we try to explain why that route was chosen and not maybe another alternative route following a different line. So it was a reveal preference study. And based on the different alternatives, for example, one alternative might have a different waiting time, maybe have different walking time, travel times. So what we did was come up, okay, for an aggregated measure called a utility function of a route based on all the characteristics and compare the different utilities of the different alternatives and try to explain and come up with this, with how the weights of the parameters are inside this utility function, try to explain and come up with the different perceptions and preferences in terms, for example, on how they value travel time, walking time. I have another question from Carl about what we have published or reported. Part of the first part of the study about the metro system in Santiago, at least, is already published. It was published a couple of years ago. If you're interested in this paper on other reports, you can go to our center website, www.brt.co, and there you can find all the reports and interesting matters in terms of publication, not only of my research of behavior, but different researches in behavior of all our partners. And the second part of the study, dealing with the entire system in Santiago, it's something that, as I mentioned, we're working on right now. We are close to finish, and maybe soon we'll have some news in terms of reports and publications. Another question regarding the data. If I use stated preferences, as I mentioned before, this was an entirely revealed preference study. We didn't come up with a stated preference. A stated preference, for those of you who don't know, it's a questionnaire, a survey, when the individual are put in hypothetical situations. Let's say, okay, let's assume that you want to make this kind of trip. Which route would you choose? Which is quite hypothetical. What we did was actually analyze the actual revealed preferences, the actual choices of the travelers. Are there any other questions? I have a question from Cesar. Are users using any smartphone application to get suggestions on planning their route? How do you measure the level of awareness of the system? That's a really good question. Unfortunately, when the survey was conducted, it wasn't conducted by us, but was conducted by Metro, so we had no control over the questions. No information about how they choose the routes was obtained. We cannot separate between people that are, first of all, commuters that make the trip pretty much every day, from those who are maybe tourists or are doing an exceptional trip. So, and of course, the level of knowledge of the alternatives is different in both cases. So we cannot differentiate between these two types, and we also don't have any information regarding how they plan their route, for example, using a smartphone application, or maybe going to the Metro website for the journey planner, or any information regarding that. So it was really not possible to measure the level of awareness of the system, how familiar they are with the system, at least for the Metro study. And that's why, for the second study that I mentioned, one of the variables that we're actually using to understand, in particular, the strategies that people are taking is how frequent the trip is for them. If they make the trip every day, at least once a week, once a month, or maybe if they have never made the trip and it's the first time they have to make that particular trip. So, and we included that question, and that question was, as I mentioned, really important, at least in terms of understanding the strategies people take. Another question from David: did you get values relating to comfort and other factors specific to different modes? For instance, did people value traveling by rail higher than bus? That kind of a refination of the model is something that we're working right now. It was not present in the results, of course, but I can say that yes, there are differences in terms of the value of travel time, at least. In metro, is lower than in bus. In bus, maybe it's less comfortable and maybe more crowded. It depends on the case. But yes, people tend to travel, if they can, by metro or express buses rather than by bus. So there are differences across modes. But one thing we found related to this is that more important than the mode per se is how crowded the mode is. Of course, if you travel in a really crowded metro, it would be much worse than traveling in an empty bus. That's for sure. So more important than the actual mode is the characteristic of the mode, how crowded it is, how the stations are, things like that. But yes, there are also some differences on the modes. Another question from Carl: I have found that people care about the number of stops on their journey, even with the same travel time. There are reasons to believe that people like flow. If I understand the question, you're saying that people would like to travel with more people, like they like flow? Because one of the variables in terms of the first part of the question is the number of stops in their journey. That's actually true. There's this idea that the higher the number of stops you have to go along the way, the longer it will take. It might not be the case. It might not be the case. But if you look at the map and you don't have any additional information, maybe you say, okay, I have to make 2 routes, go through 10 stations, maybe 5. I'll take the one that goes through 5 stations, because that should be quicker. And that actually happens. That was one of the variables we included, and we found that was significant. Are there any more questions? A question from David: how many of your respondents didn't consider a common line? 2/3. That's quite a lot. 66.6% did not consider common lines having different lines to take. So they could consider common lines, but 2/3 did not consider common lines, which at first was quite a shock to us to understand, okay, why most of the population having the different lines to make the trip faster, at least in terms of waiting time, because if you take the first line that passes through the station, you wait less, of course. Why the majority of them didn't consider common lines, which being common lines something that seems to be attractive to travelers. And we found out, okay, that there are differences along the population. And as I mentioned, different people with different income, different maybe educational levels, have different levels of abstraction and possibilities of actually looking at the neighborhood and understanding and analyzing that there's not only one alternative, but maybe many alternatives to make the same trip. also the age or how familiar they are with alternatives is really important. So yeah, at first it was quite shocking that find that most of our population didn't consider command lines when they had the possibility of considering them. But when we analyzed the characteristic of each individuals, the answer was pretty clear. The higher the income, the higher the educational level, the higher the knowledge of the network, the higher the probability of considering command lines. Another question from Carl. Do you think the command line thing will change in the future? For example, more use of travel planners. That's an excellent question. The thing with command lines is that they appear on frequency-based systems, on systems that you don't have no idea of which will be the next bus to pass through the station, for example. It's only based on the frequency. There's no timetable. The main planning tool developments have been done, of course, in the US and in Europe, where the transit systems tend to have timetables. So with timetables, there's no command lines. That's why no planning tool, at least, has this command line thing. But in developing countries like Chile, we have been working to come up with a tool that actually includes these command lines. And when you offer the traveler a route for the query, you don't only say take this line and that time take the other line, but instead you take, okay, you're at the stop, take the first line that passes among this set of lines, and then take the first line among the different set of lines. So yeah, this is definitely something much more recent in terms of planning tools, travel planners. But yeah, that's something that at least we are doing right now, and we expect that in the short term, this kind of feature would be introduced in our Trans-Santiago planning tool, and hopefully in other planning tools around the world as well, where this is important with frequencies, not timetables. We have a question from Francisco. From those that don't consider the command lines, they still decided the route they always use. How do you think they made the decision if they didn't consider all options? Well, I think I'm trying to put myself in the head of one of these people. Before, a little of context. Before Trans-Santiago, which is fairly a new system, was implemented in 2007, we had a completely different system on which you usually had one bus to take from origin to destination. So people were really used to taking only one bus, knowing the bus you're taking and taking that bus. But then the system changed. Its design changed. Now we have a feeder trunk system on which, in many cases, there are more than one line that you can take, at least from one trip leg. So the first thing, I believe that people are still used to thinking in the previous system. It's hard to adapt your decision-making process. And when you're used to only taking that one bus, and you know the bus that you will take, you make the trip, you take the bus, you get to the destination, you're happy. But there's not many incentives maybe to try to come up and try to analyze and find different routes. Maybe, what happens if I don't take this one and take the other one? What can I do? So I think people don't consider common lines because they are not aware that there are other lines that they could take. It's only a matter of information and how well they know the system. Another comment from Carl. I know research that says, that claims at least, that people make decisions about habits. They stay with the habit. That's entirely true. I mean, not as part of this research, but as part of another research that we conducted in Chile, precisely because of this system change, which was a panel survey that we follow people through at least 3 years, analyzing their decisions. And inertia is something really, really important. If you know how to make a trip and you're quite happy with the trip, that's it. You'll make the trip that way, and you won't try to find better ways. So as soon as the traveler is comfortable with the decision she's making, she'll continue making it. There's no incentive. Only when you make big changes to the network, for example, building a new metro line, maybe those are the situations people would say, okay, you have a fairly new system, let's try to think again how to make the trip. But yeah, inertia and habits are something really important and something really difficult to break, to take people out of them. And that's actually a challenge for the planners when you want to come up with better solutions. Okay, if we don't have any more questions, we're right on time. I would like to thank you all for assisting this webinar. I really hope that it was interesting for you. Maybe I hope that I answered your question. If you're interested in this research or other research that we are conducting in the BRT Center of Excellence, please log on to our website. And please be aware there will be more webinars. This is a monthly webinar series. So please we will be sending you more emails. And thanks again to everybody for this. Those of you who are interested in this presentation of this material, we have your emails, so don't worry. We can, maybe if you're interested in having this presentation or other presentations, just let us know. Thank you very much.